Hey folks, in the previous session we have performed couple of basic analysis like what is the minimum length of the questions of question 1, question 2 and some more other stuff related to our histogram analysis. So let's go ahead and try to solve some more problem statement which is all about, hey, can you analyze the distribution of our word share feature? Cool, let's try to do this. So the moment I say data of word underscore share, the moment I press tab, this is exactly that feature. Let me execute. These are all the values that I will end up getting. Now, what we need to do is we need to analyze its distribution. Again, just to analyze its distribution, what I can do is I can just call a distribution plot function. I will say, cool, let's try to call this distribution plot. Let me just execute this line of code. Just in a couple of seconds, you will end up getting an amazing distribution plot of this word underscore share feature. Now it says, hey, probably most of the values are ranged between 0.2 and 0.3. If I will exclude this 0, that's what it actually stands for. Now let's try to understand more about this feature. Let's try to understand this. So what I can do is I can say, cool, again in this is a duplicate feature. As it is of binary format, we have value as 0 and 1. Wherever it is 1, it means they are similar. Wherever it is 0, it means they are not similar. So we will say, hey, can you analyze the distribution of word underscore share where my is duplicate is 0? Similarly, hey, can you analyze the distribution of word share where my is duplicate is 1? Hey, can you do this? So what I will do is I will say, cool, first and foremost, let's try to access all those observations where my is duplicate is equals to 0. Again, this is exactly filter. Let's try to pass this filter in my data. Let's try to pass this. The moment I do this, this is what I will end up getting. Now, from this entire data frame, we have to just access our feature, which is all about word underscore share. Cool. Let's execute. This is what I will end up getting. Similarly, the moment I say if this is duplicate is equals to 1, if I will execute, these are the different values that I will end up getting. Now on top of this, if I will say, can you create its distribution plot? So I will say sns dot distribution plot, and similarly let's try to call a distribution plot on top of this. I will say distribution plot of this, similarly distribution plot of this. Cool. Let me execute this line of code. On the other hand, let's try to execute this line of code as well. Now, one thing that you will notice is where my questions are not duplicate or are not similar, this is the distribution of the word share. Whereas this is a distribution of word share where my questions are similar. Again, just to understand more, what I can do is I will try to copy the code and I will try to paste in the same cell. Just to understand more about this feature, let me execute this line of code. Now, in this visualization, we can say, again, just to make it more clear, first and foremost, let's try to assign your own color. I will say color is all about red. Similarly, here, my color is all about, let's say, blue. I will say, cool. Let's try to execute this line of code again. Now, from this entire distribution plot, we can say there is much more word share when my questions are duplicate, because look at the area that gets overlapped. Again, majority of the area of is duplicate equals to 1 comes under this area. That's why we can say from our distribution, we will clearly see there is much more word share when we have is duplicate equals to 1. That's an in general conclusion that you can showcase. Now let's try to understand more about this feature. Again, if the distribution of features are fully separate, let's try to understand all the scenarios. The first is, let's say if the distribution are fully separate. The second scenario can be if they are highly overlapped. Whereas the third scenario can be we have some separation, along with some overlapping, Imagine this is a third case. Let's try to touch upon each and every case. Again, let's try to touch upon, let's say, this one. Imagine I have two distribution. Let's say this is the first distribution, and let's say this is the second distribution. So this is typically the case. This is the first case. If this is a case, and let's say this is a feature X, and let's say we have some target variable, let's say is underscore duplicate. Imagine, let's say this is a distribution where my is duplicate is 0. This is a distribution where my is duplicate is 1. And this is a distribution of some feature X. So if I have such a distribution, it is nothing but my best case. Because in general, it is just separating both the classes. Let's say this is my class 0, and let's say this is my class 1. So this is my threshold. It means any data point which is less than this one, this will come under class 0, and any data point which is greater than this one, this will come under my class 1. This one is exactly my best case. Now let's try to touch upon the second scenario, which is all about let's say we have some scenario where distributions are highly overlapped. Let's say this is a distribution with respect to class 0, and let's say this is a distribution with respect to, let's say, class 1. So here you will notice is we have extremely high overlapping over here. Hence, this is a worst case because it is extremely difficult to find a threshold value over here. Whereas, let's have a touch upon the third way. Let's say we have some separation. Along with some separation, let's say we have some overlapping. Let's say this is a case. So we can say that's an average case. Average case basically means this feature is neither perfect nor bad. It is somewhere useful. Again, if we have such scenario, this feature is extremely useful. It means X is extremely useful. But if there is a high overlapping, it means this feature doesn't make any sense. And in such scenario, feature is somewhere useful. That's basically a high level overview of how you can pick up some features. Again, just to understand more, you can also think of plotting a violin plot of your word underscore common feature. Let me show you that, or word underscore share feature, as we are talking with respect to word underscore share. Let's try to plot its violin plot, and let's try to understand what a violin plot is all about. Let's try to understand this. First and foremost, if I will say on x-axis I have to mention my is duplicate. Cool. Then on y-axis I have to mention my word underscore share feature. Cool. The moment I do this, I have to mention what is my data frame. I will say data is all about data. Let me just execute this line of code. Now from this you will see this is a violin plot where my is duplicate is 0, and this is a violin plot where my is duplicate is 1. Again, for those of you who know what exactly is a box plot, violin plot is nothing but extension of the box plot. Again, in general, let me explain what exactly box plot is all about. Let me explain you. So if I will say, let's say this is a box plot. Let's say this is a box, and let's say this is a box plot that we have. And imagine I have this line. Let's try to understand what this box plot is all about. So in general, this line says this is my 25th percentile data, this is my median or my 50th percentile data, this is my 75th, and this is nothing but my minimum value. That's a high level overview of my box plot. Imagine I have some feature. Let's say Q1 length. Here we have some numerical value. Let's say 100, let's say 50. Just for a couple of seconds, just imagine these are the values. So we can say 25th percentile value is probably close to 40. So I can say its 25th percentile value of Q1 line feature is 40. It means there are total 25% observations. There are total 25% observations that are below than 40. That's what actually it stands for. Similarly, 75th, let's say its value is 80. It means there are total 75% data points that are less than 80. That's what actually it stands for. Again, just to make both the violin plot and both the distribution plot more user friendly, what you can do is, I can say cool, let's create a, let's say subplot 1, and let's create a subplot 2. Let's create a subplot 1, let's create subplot 2. On top of this, just showcase your violin plot. Just showcase your violin plot, or just showcase your box plot. That's all up to you. And on top of this, just to showcase your distribution plot. Again, this is all about just to make your plots, just to make your visuals more user friendly. Let's try to do this. So we will say it is all about nothing but plt dot subplot 1, 2, 1. Let me show you why. Let me press shift plus tab over there. It just add a subplot to the current figure. We have to just pass some number of rows, number of columns, and the index that we have. It means number of rows is 1, number of columns is 2, and I have to showcase a subplot at index 1. And here, this is all about our violin plot. This time, now what we need to do is, we need to just copy all the code. Just paste it. This time, we need to say as 1, 2, 2, because this time, it's a turn for your second index, which is all about our distribution plot. Let me just execute this line of code. The moment I will execute it, you will end up getting such an amazing visualization. Again, if you want to customize it, what you can do is, you can say cool plt dot, let's say dot figure. Let's try to assign your own figure size, which is all about fig size. I will say, let me press tab over there. So this is exactly fig size, and it is all about 12,8. Let me just execute this line of code. Now you will see, this is your amazing violin plot, and this is your amazing distribution plot. Similarly, you can do the similar stuff for your word underscore comma. What I can do is, I can just paste all the code, just try to customize it as word underscore common. Just try to customize it word underscore common. Just try to customize this one as well as word underscore common. Let me just execute this line of code. The moment I will execute it, now one thing that you will notice is, from this distribution plot, it is extremely harder to analyze this. Of course, in context of distribution, it is extremely harder to analyze, as both are extremely highly overlapped. But from this box plot or from this violin plot, we can analyze up to some extent. Again, in context of machine learning data science, you have to experiment with a lot of features like this using a lot of plots. Now from this, we can come up with this conclusion here: the distribution of the word common feature in similar and non-similar question are extremely highly overlapping. So that exactly is a conclusion that you can showcase to your business team. So that's all about this session, and if you guys have any issues, any doubt, feel free to ask with us in the Q&A of the course. That's all about it. Thank you. Have a nice day. Keep learning, keep growing, keep practicing.